Okay, welcome to Algebra 2, Unit 3, Lesson 1, Part 3. So as advertised, we are parking ourselves in Lesson 1 to fully cover this factoring as much as we possibly can. So we're going to begin this lesson with a discussion of the warm-up. Now, if you are watching this video from home and you weren't in class to see what the warm-up was, I'm about to tell you what the warm-up was as soon as I can find a pen. Here's my pen. If you go to Desmos, there is an activity assigned that says this. It says difference of squares, okay? And what I'm going to suggest, difference, there we go, of squares, is that you pause this video, right? We're not even a minute in, but I want you to pause it, go over to Desmos, and work on that particular assignment in Desmos. And the directions for the warm-up are just look at some patterns. What do you see? Okay, so pause the video, and then when you've had a chance to look at those, come back and unpause it so that when I'm doing the summary of what you should have noticed, you'll actually have looked at it. Okay, so I hope that you did do that. So the first question to discuss is, what did you need to get the diagonal? And when I say top diagonal, what I mean is the top right and the bottom left. Okay, what did we need to get those areas to add up to? And if you're thinking about like, well, what did these problems look like? They look something like that. And so you would have your x squared, and then you would have your negative 16, and then there actually isn't anything in the middle. So the question that I'm trying to get you to notice is, okay, well, what would it have to be if there's nothing there? And so hopefully in your thoughts, you came up with this, that if there are no x's there, then no x's would translate into 0 x's. And so what you're trying to get there is you're trying to get those to cancel each other out. You're trying to get them to add up to 0. What did you notice about the values that you put in those boxes? Well, I hope that you noticed that they were things like negative 4x and positive 4x, or negative 5x and positive 5x. I don't actually remember what the numbers were that I put in that one. And the word for that, the math word for that, is they are opposites. Okay, so when we're talking about the positive and the negative of the same thing, the math vocab word for that is opposites. So you should have noticed that whatever went in those boxes, you had positive and negative of the same thing. Next question is, what did you notice about the answers? So the answers probably looked something like this. You would have two things in parentheses, and they would be the same things, except one of them had a plus sign and one of them had a negative sign. And that came from the fact that when you filled in the top right and the lower left there, that you were putting in opposites. And so you would see that opposite start to show up in the answer. There is a vocab word for that as well. That vocab word is conjugates. So that's actually the word that describes factors that look like this, that have the same thing except one's plus and one's minus. And they are super important in math and super significant because when you multiply them, the x terms, or sometimes we'll call them the middle terms, would cancel out because they'll be opposite. So conjugates have that property about them, which makes them very important. So really, really, really important warm-up. If you are trying to take a shortcut and just saying, well, I'll get the main idea, please don't go pause the video. Go and look at the Desmos. If you're doing it after I've gone over these, so be it. I still want you to go and look at them. Okay, it's still valuable for you to go and look at what those problems are. So the last question there is, why do you think this was called the difference of squares? And the hint there is, think about what the word difference means in math. When we talk about difference, we are talking about subtraction. And I'll usually use the illustration. If we wanted to know the difference between my age and your age, what operation would we do? And I hope most of you would say, oh, we would subtract. If we want to know the difference in our ages, that would be subtraction. And so when we call this the difference of squares, that's the subtraction. You'll notice that all of them had a subtraction. And then the squares part comes from the fact that the expressions involved are all what are called perfect squares. And so I don't remember what the numbers were that I put in there, but the number parts would all be perfect squares as well. And so you might have a 16, which is 4 squared, or 25, which is 5 squared. You might see a 49, which is 7 squared. And then, of course, on the other side, you would have the x, and the x would be squared as well. And so it's called the difference of squares because it's subtraction, and the two things that are being subtracted are what we call perfect squares. So there's the review of the warm-up. There will be more to come on that. All right, so what's today's new skill? What is the skill that we're covering today that we're adding into our repertoire of things that we know how to do with factoring? The question is, what do we do if the x squared term has a coefficient? Now, technically, x squared does have a coefficient. It's got a coefficient of 1. And we just we know that it's a 1. Yeah. When we say that when it has a coefficient, what we mean is something other than 1. So what do we do if the x squared term has a coefficient? So so here's a clarification. So what if we have like 2x squared or 5x squared instead of just an x squared? So what if what happens in that upper left-hand box is not just an x squared, but we have a number there and we can't get rid of it. Now, the last problem on the warm-up actually does that, and I tried to kind of lead into this by making the other number in the warm-up a 1. So the way we have been doing it is we've had like the 1 in the upper left, and then we had some other number down here. And that last warm-up problem, it put the 1 in the lower right, and then you had the number was in the upper left instead. And so, hopefully you realize that it worked the same way, but it's kind of leading you into what this is going to be or what this solution is going to look like. So before we get to that, though, let's see why this is a problem, because you might be thinking, well, I don't see why that's a problem. I would just put them in and I would just do whatever it is that we've been doing. And that is absolutely what I would expect you to do. So we're going to consider that expression 2x squared minus 5x minus 12. Notice that there's no common factor there. So in some of the earlier problems, what we would do at this point is we would try to take out the 2. And then what you'll notice is that like you can kind of get it out of the 2 and the 12, but you can't factor the 2 out of the 5 because it's not a factor of 5. And so you're stuck. You're stuck with that too. So what happens when we set up our areas the way that we set them up before? So there's my awesome box. I'm going to put the 2x squared there, and I'm going to put the negative 12 down there. Hopefully you can see that. I just wrote right over my picture there. So you put the negative 12 in the lower right. So what happens when we do this is we might start looking at factors of 12 to see what's going to add up to the negative 5x, okay? Because we know that these two boxes there have to add up to a negative 5. At least the way that we've been doing it. And so you start to look at factors of 12, like, okay, 1 times 12 is 12. I could get a 13, I could get an 11, depending on what you make positive, negative, but not a 5. We could do 2 times 6. Now that's close. I could get a 4 from that. I could get a negative 4 if the 2 is positive and the 6 is negative. I could also get an 8, but I can't get a 5. And then we have 3 times 4. That's a time sign there. And I could get a 7, or I could get a 1, or like positive 7, negative 7, positive negative 1. And that's it. That's all we have for factoring the number 12. And so like what we might think is, okay, well, this is not factorable. There is no combination of numbers that would get it factored. And the reason we're coming up dry is because of that 2. That 2 changes the game plan. It just changes what we do. And just like in the one that you did in the warm up that had the, I think it was like a 4x squared up here, and you ended up having to split the 4, okay, into 2x and 2x. Again, if you did not look at the warm up, please stop this video and go look at the warm up, okay? What we need to do is we need to take into consideration not just the 12, but the 2 as well. Both of those need to be taken into consideration when we are filling in the other 2 boxes. So I got all the way through this problem and then hit a button that forwarded me to the next slide, and you can't go back and resume your recording where you left off. So now I have to re-record everything on this slide. Hopefully it goes as well. I thought it went pretty well the first time. So here's the solution to our problem. Instead of using just the C value, which is that value in the bottom right here, to narrow down the potential numbers, we need to use both the A and the C. So that number that's right there, like in front of the x squared, complicates it. And it just means that we have to use both of those numbers when we're generating our list of candidates. So I'm not going to send you out to just do problems like this on your own without demonstrating how to do them. So we're going to work the problem from the previous slide to see how this works. So we're going to do the 2x squared minus 5x minus 12. So the good news is that we start with the same steps. Fill in the top left and the bottom right as before. So we are going to fill in the 2x squared and the negative 12. Okay, now what we noticed was that when we just used the 12, we did not come up with a pair of numbers that could work. We didn't have any potential candidates. So what we're going to do is this new step. We're going to multiply A and C together. So we're going to do 2 times negative 12 to get negative 24. Now, we do want to keep in mind that it is a negative 24, but for the purpose of generating the numbers, we're just going to use the 24. So now we're going to be factoring a slightly bigger number. That is a drawback to this, but it's unavoidable. And it's going to give us a different set of numbers. And what we're hoping is that that different set of numbers is going to have the pair that adds up to the negative 5. It's going to have what we're looking for. So what are the factors of 24? Well, I have 1 times 24. I have 2 times 12. I have 3 times 8. And I have 4 times 6. Use a calculator for that step if you need to. Okay, that's going to just depend how fast you can do that and generate those possible numbers. Really depends on how good you know those timetables and what they all multiply to. But it's totally okay to use a calculator if you need to. So now looking at that list of candidates, I'm still looking for the same thing. I'm looking for numbers that are going to add up to that middle term. And now I have a pair that looks like it's going to work. The 3 and the 8 should work if the 8 is negative. So if I have a positive 3 and a negative 8, it should work. So I'm going to go ahead and put in the positive 3 and the negative 8x. And now we can finish it as before. Now we did a problem like this earlier on where we kind of used a trial and error method for figuring out what needed to go where when you were breaking up. I think the one we did in class was a 3x squared. It's a couple videos ago, like 2 videos ago, so you can go back and look it up if you want to. But what I'm going to show you here is a little bit better way to do this. The best way to do this is to actually do greatest common factor factoring. So I'm going to look this way, and you can really pick any direction you want. If you end up factoring it in some way that snaggles on you, I don't think that's a word, snaggle. That you can just back it up and try something different. But if you look at 2x squared and 3x and ask yourself, what do they have in common? They have an x in common. And so you just factor it out that way. So literally what I did was I grouped these two together and got the common factor that way. You could also group like this way or here or here. Try to avoid a grouping that has a negative if you can help it, just because we run into the question of should you factor out the negative or not, okay? Because this is a negative 12 and it's going to come from multiplying this number and which one should be negative. So for your first one, try to find one that doesn't have a negative in it if it's possible. Okay, now we should be able to do the rest from here. So remember that the height times the base, or base times height, gives us area. The area is 2x squared, so what would have to be here? That would have to be 2x. Now we can jump down to this one. 2x times what? Okay, we're finding the area would give me negative 8x. That would be negative 4. And what I love about this method is if you feel a little shaky on that, you can do a quick multiplication, like just turn it right around and do it in that forward direction. So 2x times negative 4, yep, that gives me negative 8x. Now we can do this one over here. X times what would give me 3x? Well, that would be 3. And then use the remaining one as a check. Okay, so the one we haven't looked at is the lower right. Negative 4 times 3 is negative 12. And there are our factors. So our factors are going to be 2x plus 3 times x minus 4. If you need to, rewind the video. It's only been 6 minutes since I messed up my slides. I'm going to have to actually stop the video to go to the next slide because that's what happens when I hit the wrong thing on the screen. So rewind this if you need to. And on the next slide, we're going to do one more example. We're going to try to incorporate everything that we've been talking about. And then you'll be free to do your classwork and your homework. Great. So as with the previous slide, I think I meant to animate this so that the steps came in one by one. But here we go. So we have another one. We have 6x squared plus 34x plus 20. So right off the bat, you're probably thinking, nope, those numbers are too big. You start to realize that, yeah, there's just too many number combinations. But remember back from our last lesson where the very first thing you always want to do is look for a common factor. Do all three of those terms have something in common? Was there something that was distributed? And if there was, go and try to get that out at the beginning. It's going to shrink our numbers down. So we need to do that first. If you look at this, you'll notice that 6, 34, and 20 are all even, which means that I know that a 2 must have gotten multiplied through. So I'm going to start this problem by factoring out that 2. So what would be left? 3, because 2 times 3 would give you 6. That is messy. Let's see. Do that better. There we go. This is a 17. Okay. And then this would be a 10. And some of you have noticed, when you're factoring, you're dividing. Procedurally, yes, you are. Factoring and dividing are not exactly the same thing, but they are very, very, very closely related. So if I were to ask you the question, what's the opposite of multiplication? And one of you answers division and one of you answers factoring, you would both be right, even though factoring and division are not quite the same thing. Now, this is excellent news because now instead of having a 6 and a 20, we can deal with a 3 and a 10, which are way, way nicer. So we're going to fill in what we know. We know that the 3x squared, there we go. Oh, I don't want to use green if I've got that background there. There we go. So we're going to put in the 3x squared and the 10. Now, remember the analogy that I used in class? Treat this is Thanksgiving dinner, okay? This is like you baked some bread, okay? The directions said factor, or the directions might say make Thanksgiving dinner, okay? You bake some bread. Then you take it out of the oven, you're going to put it on the counter to cool down, and you're going to use the oven to cook the rest of your Thanksgiving dinner. However, when it comes time to set the table, you want your bread, okay? So when it comes time to list all the factors, we need to remember that the 2 was a factor. We just got it out so we could use the oven to do some other stuff, okay? Now, so we can get the 3x squared and we get the 10. So the new step that we're adding is we do need to multiply the 3 and the 10 together, because if you just use the 10, all right, if you just use the 10, you've got 1 times 10 and 2 times 5, and you cannot get a 17 from that, okay? You can't get a 17 from either of those pairs. So we need a different number to try to work with. And the number we're going to work with is 3 times 10, which is 30. So that is going to be the number that we're using to generate our list of potential numbers. Now, you might have this jump out at you, okay? Or you might have to methodically list out what are all the things that multiply to give you 30. Do it with some kind of system. Do not just start listing stuff. So we have 1 times 30. We have 2 times 15. We have 3 times 10, not 4, but then we have 5 times 6. And the reason you do need to be careful about this is because sometimes there's more than one combination. So if you had a 13, say a 13 here, there's actually 2 ways you could get a 13. You could do 3 plus 10, or you could do 15 minus 2. And that's where it gets like tricky. If you pick the wrong one though, with this method, you will end up like it won't work when you get to the next step. So just, yeah, keep that in mind. If you do get stuck, there might be another pair that might work. So we're looking for a 17. And as you kind of go through, 2 and 15 is the pair that would get us the 17. So we would have like a 2x and a 15x. And now we need to do a greatest common factor, okay? So we need to figure this out. I would go for whichever one is the easiest one to get a common factor, which I think is going to be this group here, because 3 and 2 don't have anything in common, and then you have the x squared and the x. So you can get the x, that's the common factor. But you could also do it this way. Okay, so you could say, well, 3 and 15 have a common factor of 3 and then an x, or you could do this group, 2x and 10, what do they have in common? They have a 2. Like, there is flexibility there. There's no like right best way that you have to fill that out. Just if you've got something that's got bigger numbers or seems harder, see if you can find an easier way to start the problem. So what's an easier way for most of you to get the 3x is to look at this area and say, okay, what times x would give me 3x? Well, that would have to be 3x. Or you could get that same 3x by factoring out the GCF. Either way is totally fine. Just do it in the way that's easiest for you. Right here, what times x gives you 2x? Well, there's the 2. And then over here, it's probably easiest to do this one. If you have 2, what would this have to be to get the 10? That would be 5. And then we'll use this square here to check it. 3x times 5 does give me 15x. So you'll notice that there's a bunch of ways you can do that. If you have something that isn't checking, okay, like you're not getting it right, go back, check positives and negatives, and then check and see if you didn't miss one of the combinations or if there's another combination of numbers that might work. Those are the things you would do. There's not tons and tons of examples that do that. Just like they are out there. Okay, so that's what you would try. And then if you're still stuck and it's just not coming, that's when you ask. That's when you ask, like, okay, I'm stuck on this. So let's put our Thanksgiving meal together. So we have a factor of x plus 5, and we have a factor of 3x plus 2. And then don't forget the bread. We had the bread baking earlier, but we need to put it on the table with the rest of our factors there. So there we go. Now that problem took me about 7.5 minutes. That was with a lot of explanation of what's going on. You might, without all the explanation, you might take 7 minutes to do the first one that you try to do on your own, and then they should get faster. As with anything, the more that you do it, the more you get the feel of what you're doing. The bigger the numbers, the nastier this process here is. So if you end up with some, and I think there are some in the Desmos that have some pretty big numbers, just be methodical, be patient, and you want to develop a technique for using your calculator. But that is it. This is a fairly short video, only 26 minutes long. If you have questions, let me know. The classwork is Desmos 5A, and the homework is Desmos 6A. Okay, so those are the next two Desmoses that we're doing. And so if you're doing this from home, make sure that you do get that homework and classwork done as well. All right, let me know if you have questions.